The numerical model is a way of analysing a performance through movement. It's split into kinematics and kinetics. Kinematics is the study of motion or position within the body or an object, and kinetics is the forces that are used in the motion of an object or a body. These motions can be split up into linear, which is where everything is moving in the same direction at the same speed. This can then be split into rectilinear, which is motion along a straight line, and curvilinear, which is motion along a curved line. An example of this would be the downwards part of the dive, where the whole body is straight and moving at the same speed. The next one is angular motion, so this is a movement in a circular motion around an axis. So all the motion is at the same speed when going round the point of turn. An example of this would be in a somersault. As part of the dive, the whole body is rotating around the central point of the body. And the third one is projectile motion. So this is the launching of an object or person through the air. So an example of this could be high jump, when they jump and they're forcing themselves through the air, and javelin, when the force is put through the throw and the javelin goes through the air. There are different types of numerical model research. So the first one is literature. So this can be done by looking through books and journals and websites to gather information. The second one is athletes, so where athletes, what is being an elite athlete is being watched and their performance is analysed, or combined methods where both of these approaches are used. The advantages of this is that it can be done at any level, and simple equipment can be used to do so, and it also provides evidence behind the athlete's performance, so gives it a reason. Disadvantage of this is that some of the collection methods can be poor, like the footage taking, so this could then lead to false conclusions being made, and it's also quite subjective, so it can result in a poor analysis. As you also need a high level of skill to do the analysis in the first place. The first type we're talking about is different types of linear motion. So the first one is a scalar. So this is a value that has a magnitude, so how big or far something is. So this could be something like distance or mass. And then this is in contrast to a vector, so this has a magnitude but it will also have a direction, so how far something is and then with a direction, so this could be something like velocity. Speed is how quickly a body moves and the rate of the motion. It's measured in meters per second, and to work out speed you do distance divided by time taken. Velocity is also how quick a body has moved, but adding a resultant direction, so this is measured in meters per second again, and to find out you use displacement divided by time. Distance is the sum of all movement regardless of the direction, in contrast to displacement, where it's the distance along a straight line from start to finish, dependent on direction. So for example, in a 400 metre race, the distance is obviously 400 metres around the track, but the displacement is zero, as they've gone from the starting point and then finishing in the same point. Acceleration is the rate in change of speed, so it's measured in meters per second squared. It's the change in velocity over time, and the change in angle of the slope seen on this graph is the change in acceleration. So a positive line is going to be accelerating and a negative is decelerating, and a flat line represents a constant speed. Anything that then lies below the x-axis is a change in direction. So as you can see on the graph, if we relate this to basketball, this could be someone kind of moving around the court and running down towards to help to shoot a basket, so then they speed up to try and get in a good position, at this flat line, when it's a constant speed, they could just be kind of moving around to create space, and then when this line then starts to decrease, this could be them slowing down, so kind of waiting around the box, or the D, sorry, as someone's shooting, as this is this line here where it goes under the x-axis is then them changing direction, so there could be a rebound off the board where they now have to start running back in the other direction if the other team got the rebound. Forces. The first part of forces is inertia. So this is where an object's reluctance to change, so therefore needs a force to be applied to change the motion. Everything has a value in order for movement, and the value then needs to be overcome for movement to happen. So say if there's a rugby player, for them to be knocked down in a tackle, the opposition needs to have an inertia value bigger than the player with the ball. So everything will have an inertia value. So through this, it shows that you can only see the effect of a force and not the actual force happening. So for example, you can't actually see friction, but you can see the effect of friction. The types of forces are applied force, so this is through contact. There's also gravitational force, so an example of this is obviously us on Earth. The gravity of Earth keeps us standing up, and this is measured in about 10 meters per second squared when on Earth. Frictional force is the resistance between two objects sliding over each other, and drag force is the acts of kind of like opposite motion on a object. The effects of force are that it can cause objects to start moving or stop moving. So applied force would obviously cause things to start moving, and things like drag force, so like long grass, when kicking a ball, the grass creates drag and can stop movement. Change in direction or change in shape, so applied force when hitting a ball in cricket is causing the ball to change direction coming from the force of the bat, and then the ball will also change shape when it contacts with the bat, although this is very acute change, so it can't really be seen by the eye. And effective forces can also cause things to accelerate and decelerate through the amount of force. So if there's more force being put on an object, then it's going to accelerate, or then if there's less force, then it will decelerate. There are three Newton's laws. The first one being inertia, so a body that is moving in a straight line states that it will continue to do so unless something or some force is acted upon it in an external way. The second one is acceleration, so this will be proportional to the force, so the acceleration will then go in the direction that the force acts. So if you're throwing a basketball, the force comes from behind, pushing the ball forward to, say, a pass to your player or into the hoop as a shot. And the third one is action-reaction, so to every action there is an equal and opposite reaction. So for every force that is applied on an object, there's an equal one against it. Direct force is a force that's directly applied to a body through its centre of mass, where an eccentric force will then create an angular motion, so applying force to the outside of an object, causing it to rotate. Impulse is the force applied to an object calculated. This is calculated by multiplying force by time. It will show the length of time a force is applied to a body and relates to the change in momentum that can happen as a consequence. For example, if you're catching a ball in cricket, the longer you take to catch it by like taking it into your hands and into your body, it's not going to hurt as much as there's less force. Whereas you put one hand out and catch it quickly, there's going to be more force coming into contact with your hand, so it's going to make it hurt more. Momentum is the amount of motion in a moving object. It's the product of mass times change in velocity. So the change in momentum is always equal to the impulse, and it's closely linked to Newton's first law that an object will keep moving unless an external force stops it, as the momentum is the tendency for an object to keep moving once it's in motion. Stability and instability. So stability is how difficult it is to disturb a body from its balanced position. Factors affecting this could be the centre of mass and its location. The point at which the body is balanced in all directions will vary on a person's position and mass. The base of support is the points of contact with the supporting surface. So the larger the base, the more stability. And then the line of gravity, so this is the direction in which the gravity acts on a body from a centre of mass through the body to the centre of the earth. To increase stability, you will need to lower your centre of mass by getting lower to the ground. You can also keep the line of gravity between the base of support by keeping a wider stance with your legs and adding additional points of contact. So an example of this is in the box out and rebound. You need to get low to the ground and keep a wide stance to make yourself really stable and stop yourself from getting knocked over by the opponent. In some sports, you will need to intentionally make yourself unstable and decrease stability. So, for example, when diving, the performer will need to decrease the stability in order to perform the skill. They can do this by moving their centre of mass outside the base of the support, by changing body position, and the line of gravity will then no longer run through the base of support. So the base of support is also made smaller, so there's less stability. So when on the edge of a diving board, they move onto the ball of their feet and gently lean forward. So by leaning forward, the centre of mass then becomes outside of their body. So the method for different things that can be done for this analysis is that you can use force plates to measure the force, and then the camera is used for the movement. This can be in combination with Viacom. You also need to use gynometers to measure the joint angles. But things need to be taken into consideration when using the camera. So you need to make sure that the camera is perpendicular to the performer to show the correct angle. Triangulation object will need to be central to where the camera is, making sure that you get the whole body in the frame. The distance away from the action needs to be considered and kept the same throughout all of the testing for it to be standardised. You should also consider the shutter speed and frame rate, as this will affect the blur of the shot. Sampling frequency will also allow for more data to be collected, so 1000 per second is going to obviously allow you to get more data. For the lens, you should look at the zoom and the focal length and the focus, making sure that it's the same for all. Things that could be done with the perspective error is where you're in the wrong view and capture the action. So if you're not eye level with the action, you'll get a skewed view of what's happening, so you need to stay in level. And vertical reference, so you'll use a meter ruler in the view of the camera to calculate distance moved in the action, so it's used as a judgment point to make sure that it's accurate and is allowing you to add a scale. The implications of this is that poor data collection methods and poor footage can be taken, which then makes it difficult to analyse after the research, as you haven't collected good or clear data that allows you to do so.